Hi everyone, and welcome to the Team Aviation educational series that we've developed for private pilots to help you learn with team. This series allows us to educate you on short topics that will enhance your safety, your proficiency, and your confidence as a private aviator. These videos are fantastic for those of you that are learning to fly, or maybe you've already got your private license and you're just wanting to enhance your knowledge and refresh your knowledge base from time to time. In this video, we're going to be talking about interpreting weather events. In particular, we're going to be having a look at the graphical area forecast and a terminal area forecast. We're using a case study from actually today. The weather is quite terrible, which gives us a fantastic opportunity to be able to look at the radar, then have a look at the graphical area forecast, and then also have a look at the terminal area forecast. Now, this video will allow us to read all of the forecast together, so it will help you embrace and encourage you to make sure you're always checking the weather forecasts, which we are required to do. But I find a lot of private aviators, they know how to read a forecast, but they don't really understand how to apply it in an operational sense. So today we're going to be focusing interpreting the weather conditions. The first image we're going to have a look at is literally a screenshot from the radar of the day. This will allow us to see, as you can see here, it's quite a bleak day. There's a lot of rain around, which, as I said, is a fantastic case study for us to be able to start mapping out the weather and understanding what we're seeing outside. So as you can see on this image here, we've got fairly widespread rain all over the southeast Queensland today. Our next piece of the puzzle, and this should be your first point of contact as a private pilot and any pilot, is we need to have a look at what we call the graphical area forecast. This is a screenshot of the current graphical area forecast. The case study that we're going to use through this session is to just look at the weather conditions around Archfield, Brisbane, and the Sunshine Coast. Just allows us to see exactly what's happening in those areas. So when we turn to a graphical area forecast, our first port of call is to identify the area in which we'll be operating. Now, this box here around the area is segregated around a number of different areas around Australia. So the first step is obviously identifying where you're going to be operating. The next step is to actually identify the different areas of operation. So you can see these little green lines through here. What they allow us to do is see areas of similar weather patterns for the day, which allows us to really hone in on that area so we can see what to expect for our flight within 4 hours in case here in area Alpha 1. We can then move across to the main part of the graphical area forecast. We can see here the title, Graphical Area Forecast, Surface to 10,000 feet for the Queensland South area. This is the time at which it was issued by the Bureau. So we've got the year, 22, the month, the date, and the time. We then have our validity period, the month, or correction, the day, the time, and that validity period. So you can see here, this validity period is, of course, 9 a.m. until 3 p.m. local time. When we go into the actual content of the graphical area forecast, we can see here area alpha, which of course we are operating from when we're operating around Archfield and Brisbane. We can then see 3 different columns. The first column is the surface visibility and the weather. Our second column we can see is the cloud that we can expect in those areas, icing, and the associated turbulence. And then we have the third column here, the freezing level. So today, primarily, we're interested in what's happening in area alpha and more specifically, area alpha 1. So if we read through this together, we've got areas of visibility greater than 10 kilometers with nil weather. We've got scattered stratus with bases 1,000 to 3,000 feet over land. Now that's broken in area alpha 1. If we recall that broken is 5 to 7 octaves. We then have broken cumulus, stratocumulus with bases of 2,000 feet up to 10,000 feet. We can also see scattered, remembering that's 3 to 4 octaves, altocumulus and altostratus, 8,000 to above 10,000 feet. If we recall from our study, alto clouds are those middle layer of clouds. So you can see here that those bases are higher than what you would expect for the cumulus and stratocumulus. In area alpha, we also have areas reducing to 5 kilometers of visibility, scattered, rain, with broken stratus, so again, 5 to 7 octaves, with bases of 5,000 feet to 2,000 feet, with areas of overcast nimbostratus, 2,000 to above 10,000 feet. The next columns we're going to have a look at, we can see references to area alpha 1. So we also have areas of visibility reducing to 2,000 meters with isolated showers of rain, scattered 3 to 4 octaves in area 1, broken stratus 5 to 7 octaves, 500 to 2,000 feet, and then broken cumulus and stratocumulus 2,000 to above 10,000 feet. We can also see that there's areas of scattered drizzle with, again, that really low layer levels of cloud as we saw in the row above. And in particular, we can also see visibility reducing to 1,000 meters in isolated thunderstorms with rain in area alpha 1. When we move across to the cloud icing and turbulence column, we can see we've got isolated CB. Now CB is cumulonimbus with bases of 2,000 feet to above 10,000 feet. Broken stratus, 500 to 2,000 feet. Now the final row we're going to have a look at is visibility reducing to 500 meters in isolated fog over the land until time 01 Zulu, so 11 a.m. local time. This gives us a good picture of what we can expect in the general area. As we saw on the radar, for the most part, the weather is pretty rubbish, but we can actually start seeing the layers of the cloud bases and we can see how the day's going to be developing. So the common theme here, to put this into plain English, is we have some areas with nil significant weather, but mostly we have widespread rain, we have reduction of visibility, and we have really low layers of cloud. We can then have a look at what we call our terminal area forecasts, which give us a fantastic picture of what we can see in and around the specific aerodromes. I've downloaded this from the Air Services Australia NAIPS program. If you don't have an account for that, I definitely recommend signing up for your account so you can access all these weather forecasts from NAIPS. If we have a look at the Archerfield terminal area forecast here, we can see Archerfield terminal area forecast, the aerodrome. This is the time it was created by the Bureau. So the date of the 12th, time 1702 Zulu. And we know that Zulu time is 10 hours behind our time. And we also have our validity period. So we've got the date of 1/2, time 18 to 1306. Now the terminal area forecasts for Archerfield are routinely issued every 12 hours. So the validity period for this TAF is 4 a.m. until 4 p.m. local time. We have the first line of the TAF here. So the wind is coming from 070 degrees at 12 knots. When we talk about the wind, we talk about where it's coming from. So it's coming from mostly an easterly, northeasterly direction. Now, this is in degrees true. Whenever you see the wind direction written down, that is in degrees true. When you hear it spoken, that is degrees magnetic. With visibility of 9,000 meters, light rain with broken cloud, if you recall, that's 5 to 7 octaves at 1,200 feet. We then can see we have a temporary deterioration of weather. So from 4 a.m. to 4 p.m., so for the entire validity period of the terminal area forecast, we have a temporary deterioration in weather from 30 to 60 minutes. Now, operationally, what that means is we have to allow 1 hour of holding fuel. So if we explore this line a little further, we can see the wind is still coming from 070 degrees at 15 knots, gusting up to 28 knots, with visibility reducing to 2,000 meters in showers of heavy rain, with the cloud being broken at 800 feet. Our final section here is RMK, which means remark. We can see here we have a T, which stands for temperature. So we have 4 different temperatures here. So that is the forecast temperature for the duration of this terminal area forecast. If the terminal area forecast is valid for 12 hours, each of these temperatures here are each individually valid for 3 hours each. We then have a Q notation here, which stands for QNH, and that gives us our forecast QNH also for the validity period of the TAF. So again, we have 4 corresponding QNHs, and that's going to give us 3-hour intervals as well. We then have a section here called a METAR. Now, a METAR is a meteorological aerodrome report, which is automatically generated. Now, these METARs are effectively a snapshot in time. They're a report, so there's no validity period that applies. Typically, they're issued every 30 minutes, and what the weather station does is it takes an average or a mean of the weather from the previous 10 minutes. So we can see here, this METAR was issued at the date, time 12, and the time of 2100 Zulu, so 7 a.m. local time. It is automatically generated with the wind of 070 degrees at 8 knots, visibility of 9,000 meters, overcast cloud at 4,400 feet, with a temperature of 22 and a dew point of 20. The QNH is 1015. The remarks for our METAR include our rainfall here. So we have our rainfall in the last 10 minutes, and then we have our rainfall since 9 a.m. local time. We'll have a look at one more TAF now, and this is for Brisbane. So it just allows us to have one extra opportunity to read through that. So once again, we have our terminal area forecast for Brisbane. This is the time at which it was created by the Bureau. And this is the validity period. So it's valid from the 12th at time 2100, which just so happens to be 7 a.m. local time. And it's valid until the 14th at time 00, so 10 a.m. The wind is coming from 060 degrees at 14 knots. Once again, the visibility of 9,000 meters with light rain, scattered cloud at 1,200 feet, so 3 to 4 octaves at 1,200 feet, and then another layer of broken cloud, 5 to 7 octaves at 2,000 feet. We have our tempo, so once again, a temporary deterioration of weather from 30 to 60 minutes, requiring 60 minutes of holding fuel from an operational standpoint. And this tempo is also covering the entire validity period of the TAF. The wind is coming from 070 degrees, remembering that's true, 15 knots, gusting to 28, visibility reducing to 2,000 meters, showers of heavy rain broken at 600 feet. So we can see here that based on the radar, the graphical area forecast, and then drilling down even further into our terminal area forecast, what we can expect today is widespread rain, really low clouds, and a reduction in visibility. If you want to learn more about reading terminal area forecasts and graphical area forecasts, I'll post links below to some really great resources that have been published by the Bureau of Meteorology. I hope this video has helped you interpret the TAFs, explain and understand a few operational requirements. And if you've got any questions, feel free to post them in the comments below. Thanks for joining us, and we hope you enjoy all the videos that are upcoming with our Learn from Team series.